Welcome to this explainer. If you're sourcing, buying, or working with spun-bond non-woven fabrics, you already know the industry has a totally favorite number, right? GSM. But today, we're going to completely dismantle this obsession. We're breaking down exactly why relying on this one single metric is causing massive headaches for buyers all over the world, and what actually drives fabric quality.
All right, so let's just make sure we're on the same page. GSM stands for grams per square meter. That's it. It's simply a measurement of the physical weight of the fabric per unit area. It literally just tells you how heavy or light a piece of material is. Nothing more, nothing less. Now, don't get me wrong, it is a super practical metric for basic categorization. On one end of the spectrum, you've got your 20 GSM fabric, which is a very lightweight material you'd see in hygiene or light medical products. Then, on the other end, you scale all the way up to 90 GSM, which is a heavy-duty industrial material. So yeah, it provides a really great baseline. But here's the thing, this simplicity leads B2B buyers into a really dangerous trap, and that sparks the central question for our explainer today. Does a higher GSM, meaning a heavier weight, actually guarantee a better quality, more durable product? Well, the industry usually assumes yes, but the hard facts, they say absolutely not. So here is our roadmap for today. First, the great GSM obsession. Second, factor 1, fiber distribution. Third, factor 2, thermal bonding. Fourth, factor 3, raw materials. Next, we'll look at a tale of two fabrics. And finally, metrics that actually matter.
Let's jump right into part 1, the great GSM obsession.
Why is everyone so hooked on this number? Honestly, this obsession stems entirely from convenience. Think about it. GSM is so simple to translate across language barriers. It's incredibly easy to compare across international suppliers, and it just fits perfectly onto a standard purchase order. But this convenience creates a really dangerous false assumption that heavier automatically equals stronger. I mean, an agricultural crop cover and a medical gown might both be 30 GSM, but their performance demands are entirely different, right? Moving on to part 2, let's look at factor 1, fiber distribution. See, when fibers are evenly distributed across the fabric, the strength is totally consistent. There are no weak points, and tear resistance naturally improves. But if a fabric has an uneven internal arrangement, it creates these invisible weak zones. And those zones, they will tear unpredictably during handling or installation. Meaning, two fabrics with the exact same GSM will show drastically different durability, all based on their internal fiber arrangement. It's like a hidden lottery.
Okay, that brings us to part 3, factor 2, thermal bonding.
You see, spun-bond non-woven fabric doesn't just magically hold together. Its strength is basically forged through thermal bonding, which relies on a very specific recipe. We're talking precise temperature stability, super strict pressure consistency, and highly controlled cooling. So what happens when a manufacturer completely messes up those variables? Well, poor bonding creates dangerously low tensile strength. The fabric is just going to tear easily under real-world loads, it'll suffer from poor elongation, and it entirely lacks structural balance. It might feel heavy enough in your hand to pass a standard GSM test, but believe me, it will literally rip apart the moment it faces real stress out in the field. All right, on to part 4, factor 3, raw materials. You can have a really heavy fabric, sure, but what is that weight actually made of? Virgin polypropylene offers much higher consistency, superior strength, and super stable processing behavior. On the flip side, recycled material might look great for lowering the cost, but it introduces wildly unpredictable performance and highly inconsistent fiber quality. Basically, a heavy fabric made of cheap recycled materials is going to fail way faster than a lighter fabric made of pure virgin PP. And to make things even more complicated, you have these hidden production line instabilities. Spun-bond production is actually incredibly sensitive. Just a tiny fluctuation in machine line speed, a slight drop in air pressure, or even a minor cooling system inefficiency can create microscopic thickness variations. Suddenly, your whole roll of fabric is just riddled with mechanical weak zones, zones that a standard GSM scale is completely blind to. Let's make this a bit more real in part 5, a tale of two fabrics.
So, let's put this theory into practice. Imagine two agricultural fabrics. On paper, both fabric A and fabric B are exactly 30 GSM, but we have to look beneath the surface. Fabric A has a uniform layout, uses virgin PP, and has stable thermal bonding. Fabric B, though, has slightly uneven fibers, uses mixed materials, and has some minor bonding inconsistencies. The real-world result? Fabric A actually lasts twice as long in the field.
It's a game changer. And here is the harsh reality. Ignoring these hidden factors is incredibly expensive. For professional buyers and importers, being misled by specification sheets that only list GSM leads directly to catastrophic end-use failures. We're talking severe customer complaints, massive financial loss from having to do replacements, and ultimately totally destroyed supplier credibility. Seriously, this isn't just about fabric anymore. It's about business survival. And that leads us to our final section, Part 6, Metrics That Actually Matter. Experienced importers know they have to look entirely past GSM and rigorously evaluate the actual structural metrics. You should be asking your suppliers about tensile strength, like exactly how much force can this fabric take before breaking. You need to know the elongation rate, which is how much it stretches before failure. You need tear resistance to defend against punctures. And depending on your specific industry, you absolutely must evaluate things like air permeability and UV resistance. Ultimately, remember this: you are buying a solution, not just a weight. I absolutely love how our source material sums this up. They say, focusing only on weight is like judging a car only by its weight without checking its engine. It's literally the perfect analogy. You wouldn't drop thousands on a 2-ton vehicle without actually knowing if the engine works, right? So why on earth would you buy miles of fabric based purely on a scale?
So, as we wrap up this explainer and you head into your next major procurement cycle, or maybe you're just evaluating your current supplier, I want to leave you with a really critical question. Are you just paying for a number on a scale, or are you actually investing in reliable performance? Because at the end of the day, true professionals do not just buy GSM, they buy performance. Thanks for hanging out with me today. Stay focused and keep asking those tough questions.